Hi everyone, welcome to the video. This topic is perhaps the one of the most confusing topics for students in math methods, and there's a couple of reasons for that. It's because of the usually to do with the wording of how things are described um, in the textbook or the exam or wherever it might be is a bit confusing as to which order things happen in and where the dilations are being applied to, etc., etc., etc. But I'll go through a couple of these things today, and I'll give you a method that will, as long as the wording is clear, you'll always get it right, and so you'll always be fine. So we'll have a look at that in a second. But just to sort of rehash, we know that if you have some sort of equation, I'll just write down anything here. 2x minus 1 plus 5, 4. Okay. So we know we've seen sort of equations like this a lot, and so we know what's sort of happening to the particular function. So firstly, we have sort of a dilation. So this 3, what that does is it stretches it up in the y direction. So it multiplies it by 3 in the y direction. So that's what the 3 does. What does that 2 do? That 2 does the opposite of that, and so it sort of shrinks it down by a factor of half. By a factor of half in the x direction. Okay, so that one belongs to the x direction. And then I didn't put any negatives on here, but I'll talk about that at the end. What does this -1 do? That -1 moves it to the right by 1. And what does this 5 do? That moves it up by 5. So we know all these things already. Um, so, um, and what about negatives? I'll just put it in green. What if we had a negative out the front? Well, that affects the y values, and so that sort of flips it upside down. It reflects it in the x-axis. It reflects it there. If you had a negative in front of the x's, so in there, what that would do is flip it from left to right. So reflect it in the y-axis. And so we know all these things. We've been doing these for a year and a bit now, and sort of see them in quadratics, seeing them all over the place. And we've got that. And so, like, if we just go to, like, say, Desmos, and you've just got a function here. So this is the square root of x, and I've already entered in sort of my bits and pieces here. What does the value of a do? Well, it stretches it in the y direction. So if I increase it, it stretches that out in the y direction. What about b? Well, if I increase b, it squishes the graph up. You can sort of see it's getting squished up. It's getting smaller. So it has the opposite of effect of the A. Okay, so it's got a getting squished up. And what does the value of H do? Of course, H, it will move it to the right, okay, because it's X minus H. And what does the value of K do? It lifts it up. So we've seen all these things before, we know. And what happens if A is negative? If it's negative, it gets flipped in that reflected in the parallel to the y-axis, so it gets flipped that way. You can sort of see it's getting flipped from one side to the other. And what if b is negative? It gets flipped in the y-axis, sort of in that direction there. And so we know all these things, and we've been doing these things for a while now. Okay, so in general, we can sort of write down what happens in general. So I'll just get rid of all this rubbish, and no, in fact, I'm not going to write it down. That explanation should have been enough. You know all the bits. So if you've got that A stretches it up and down. That X, oh sorry, not the X. Brain stopped working there. That B stretches it out this way and this way. The H moves it to the right, and that K moves it up. We know all these things, and a negative out the front there will flip it up and down, and a negative out the front of B, so negative there, will flip it from left to right. And so that's what's happening in all these things. That's enough for us to be able to write down the transformations of everything. Just one last thing before I do an example of this is the order that we write things in is actually really important. And I always think of dirt. So dilations first, reflections second, and translations last. The first two actually don't matter. It doesn't matter whether dilations or reflections are first. It doesn't actually affect anything to do with the graph. but translations must be last. If they're not last, they mark everything up, and you'll sort of see what happens if you start doing translations first, because then the dilations affect those and start timesing them by 2 and halving them and that sort of thing, and it totally throws the translations out of whack. So unless you're asked or told differently in the exam question, you won't be. Follow the pattern. So dilations and reflections first, but then translations definitely last. So remember dirt, that might help you. Let's have a look at an example. So let's say you've got the graph of 1 over x, y equals 1 over x, and it's transformed into that beast there. So let's have a look at what the transformations are here, okay? So firstly, I can already see that it's got this sort of 2 out the front of the x, and we don't like that because we want to sort of remember what I just said, is that because of the translations happen after the dilations, we need to make sure we get that x by itself. So what I'm going to do first, if I can get away, is just rewrite this slightly, and I might also just write it in a slightly different way so you can sort of see a little bit clearer. I'm going to pull that 2 out the front of this, and so you've just got this 1 over, and you'll see that it looks a bit closer when I write it like this to what we had above. So if I take that 2 out, what will be left over inside the bracket? So I'm taking out a factor of 2, so that'll be x plus 3 on 2 if I expand that out, and there'll be a plus 2 up the back line. Okay, now that we've got it in this format, it's actually quite easy to see sort of what's happened here. Okay, so we'll just quickly talk about it. Whoops, I don't know what I did there. So that plus 2, that will be lifting it up by 2. This plus 3 on 2 will be moving it to the left by 3 on 2. This 2 here, what that will be doing is it will be squishing in the x direction, will be squishing in by a factor of half. Okay, so it's 1 over 2. It's halving that. If it was a 3, it'd be a third. It would be thirding everything, so it's squishing it in. This 2 will be stretching it up. It'll be doubling, so it'll be timesing by 2 everything in that direction. And that negative there, that will be flipping it upside down, okay? So it'll be flipping out from the top to bottom, okay? So now that we've done this, let's write down and let's use the language since I've already I'll go to blue. Let's do the first thing. Okay, so let's just do dirt. So dilations first, okay? So it's dilated. Oh, my screen gets a bit rough. Dilated by a factor of 2, and this is the one in the y direction, so this is this one here. Sorry, I'm scribbling way too much. That one's in the y direction, and so what I like to say is from the x-axis. Okay, so from the x-axis, it's getting squished up and getting stretched up and down. What's the other dilation that's happening here? It's also dilated. Wish I could spell. Dilated by a factor of half. From the other one, from the y-axis. Okay, so that's what that 2 is doing. It's dilating a factor of half from the y-axis. So then my dilations, we only have one reflection. So reflected in. So this negative here, that flips it up and down. So it's reflected in the x-axis, reflecting it up and down. And finally, we've got a couple of translations. I'm just giving myself a bit more space here. So my last thing that I do is my translated. So translations, translated 2 units up. That's that plus 2, 2 units up. And translated 3 on 2 units. Which way are we going? We're going left. Okay, because it's x minus h, so the value that's actually sort of gone towards the left. Okay, and so that's the answer, and that's the sort of the language that you're expected to use in the exam. So using the dilated factors reflected in the x-axis, dilated from the y-axis or from the x-axis. Similarly here, from the x-axis there, you could also say parallel to the y-axis. However you want to say that, as long as it's nice and clear to the examiner so that they know what you're talking about, okay? Now, let's have a look at that bit's not controversial. I think most students are pretty comfortable with that by this stage, but these are the sort of the more controversial part because of the order things that are applied on. And it gets really, really confusing doing these sorts of questions when you actually have a look at it. And what I'm going to show you is the method that I use, and it just avoids any confusion. It just makes it logical and straightforward, and avoids all of the sort of like, what the hell is going on type feelings that most students get. Okay, so what I'm going to do is I'm going to write down y prime. Okay, so you've probably seen this method other places, and x prime. And what I mean by y prime and x prime is that this is y new. So that little dash, that little prime means the new. So I'm going to be talking about the new, the transformed graph. Okay, because we've got this old graph here, this old graph y equals sine x. We're going to be doing a bunch of stuff to it. And we're going to end up with this new graph. And so y dash is the new stuff, all right? And y is the old stuff, x is the old stuff. The primes are the new ones. So what we're going to do is we're going to go in order, and we're going to go through these. Again, with the order is really important. As I sort of talked about dirt before, the order that these are written in is the order that they want you to do them in. To be honest with you, in like say textbook questions, they're not always very good at wording these so that you know that that's the order that you're supposed to do it in. But in the exam, they're always really clear with the order that things happen in. So just so that you know, it's actually not as hard in the exam as what it is in the textbook sometimes to figure out what the hell is going on. So here we go. So firstly, what is my first translation? And so we're just going to write down exactly what's going on here, and then I'll show you what we do. So translated 2 units to the right. So my x's are increasing. I'm just going to put an x here, and I'll put a y here. So firstly, my x's are increasing. So I'm just going to go +2. Right, so that's the first step done. Second step, dilated by a factor of 3 from the x-axis. Okay, so from the x-axis, so it's getting stretched up and down from the x-axis. So that's the y's that we're talking about here, and it's getting a factor of 3. So the y's are all getting multiplied by 3. That's the second one. Done. Next step, reflected in the y-axis. So the y-axis is there, and so it's getting flipped from left to right. And so what that's affecting is that's affecting the x values. So the x values are becoming negated, okay? And so what I've got here, I'm going to have to negate, but because the order is important, so I'm negating everything inside there. So I'll put brackets around there. I'm negating everything in there to make it flip the whole thing, not just one part of it, okay? So that is done. Translated 1 unit down, that's affecting the y value, so y is going down, so I'm going to subtract 1 from my y values. There we go, that is done. And lastly, dilated by a factor of half from the y-axis, okay? So what's happening is that's sort of getting stronger. That's not the way I drew it before, so I'll stay consistent. It's getting a factor of half from the y-axis, so that means it's affecting the x values. And so what that is affecting the x value. So I'm going to be putting a half out the front here. I've just got a negative here, so I'm just going to delete that, and don't let me forget to bring that back in. So I'm just going to make that negative half out the front there. Okay, so that half is dilating by a factor, that half just goes out the front of there. So they're the transformations. So that's like complete. That describes all the transformations, but it doesn't give us our equation. What we need to do is to put this back into here, and that will give us our transformed equation. So let me just do a little bit of work here. So firstly, I need to rearrange y in terms of y prime. Okay, so forgive me for sort of stretching it out down here. So I'm just gonna rearrange this first. Okay, so if I rearrange that, I'll get y prime plus 1, move the negative 1 over to the other side, and then divide by 3 is equal to y. Okay, so I've rearranged for y there, and you'll see y in a second. See y. And then the second equation here, I need to rearrange this. Oh no, it's not that bad actually. So if I times both sides by -2, I'll get negative 2x prime is equal to x plus 2. And then I'm just going to do it in one step. So negative 2x, and then I'm going to bring the negative 2 over, so that'll be -2 is equal to x. I'll just double check I didn't make a mistake there. Times by -2 and then -2. Yep, that's right. So we've got these two equations now. We've got x and y in terms of x prime and y prime. And now I can sub the thing back into my original equation, so my basic equation, this thing up here, and now I'm going to put it back in here, and that'll be my answer. Okay, so therefore, put it back in, we've got y. Y is equal to y prime plus 1 over 3, and that's equal to sine, and then I'm writing x, but x is now been transformed. It is now minus 2x prime minus 2. And that's essentially my equation, and it just sort of shows you all the different things, but I'll just rearrange it in the way that we normally write things. And so what I've got is y prime is equal to, so multiply both sides by 3, so that'll be 3 sine, and I'm just going to again, I just like rewriting in the way that we used to sort of seeing it written so that we can see everything. -2, and I'm just going to take x prime plus 1 out here. I just need to do that. So just professing it like that. It's sort of much clearer. So 3 sine -2, I'll just make sure I've just done that. Yep, that's all good. So I've just tidied up that inside. And don't let me forget to minus that 1. So we need to minus that 1 from over there. -1, just rearranging. Oops, I'm just going to get rid of that circle. -1. And so that is our transformed equation. And you see it's got the y bar and x bar. That's the transformation of the original graph. And if you use that method to be able to, when you've been given instructions on what the transformations that occur, you'll never go wrong. If you follow that, it's like an algebraic method. You follow it bit by bit. You apply one thing at a time, going through the list like I did to develop these guys up here. And if you follow that and then rearrange it for x and y there, then plug them back into your base equation that you're given, then you won't have any problems. So that's my advice. Awesome. Thanks, everyone.